next little bit on exponentials and logarithms. I'm going to be working the opposite way around to what we were last week. So we're going to now look at solving exponential equations using logarithms. Okay. Now we know that these are the inverse of each other, and we know from last week that we could use exponentials to solve logarithmic equations. So same idea, we're just going to work the opposite way around today. So if I need to solve 3 to the x equaling 20, I need to inverse whatever 3 to the x is. So the inverse of that is log base 3. So if I log base 3 both sides, that cancels out my 3 to the power. So I end up with x equals log base 3 of 20. Put that through my calculator and I can get 2.73. Nice and simple. Okay. Same idea with the next one. 5 to the power of 4x minus 1 equals 61. The 5 to the power is the bit I need to get rid of. So the inverse of that would be to log base 5 both sides. That then gets rid of the 5. So I'll have 4 to the x minus 1. Remember that we've log base 5 this side as well, 61. So 4x will equal log, say, x is going to equal log base 5 of 61 plus 1 all over 4. Straight through your calculator and we'll get 0.89. Just make sure you can find your basic log buttons on your calculators, okay? So it is one of the main ones on your calculator. Just make sure you put your base in properly first. Last one I just want to show you quickly before you have a go at a couple. Obviously with this first, in order to do these logs accurately, we just want, in this case, the 9 to the x plus 10 on its own. So the first thing I'm going to do is shift the 3 across. So we'll just make it 9 to the x plus 10 equals 78. Because now I can do log base 9 of both sides. Just makes it a little bit easier. Counteracts my 9 there, so I'll have x plus 10 is log base 9 of 78. So x will be log base 9 of 78 minus 10. So that would be minus 8.02. Okay, nice and simple, guys. Just make sure you use the correct logged base to counterbalance whatever the base of your power is. Okay, so quick pause, have a go at those 3, and we will then have a look at them. Okay, so let's just have a quick look at these ones then. So 4 to the x equals 12. Opposite is going to log base 4 of both sides. Now you don't need to necessarily put this step in, but it's something that I'll always do just so I know exactly what I'm working out. So I'll have x equals log base 4 of 12. Again, using brackets because some of these later on are going to get quite complicated with lots of logs in them. So make sure that we understand what our base is and what our log is. Through our calculators, log base 4 of 12 to give us 1.79. This one, first step's got to be to move that 5 first. So I have 16 to the x minus 7 equals 19. Then we can log base 16 both sides to get rid of my 16 from here. So I'll have x minus 7 equals log base 16 of 19. So x is going to equal log base 16 of 19 plus 7. And again, straight through your calculator, log base 16 of 19 plus 7 to give us 8.06. And the last one, obviously you need to get rid of the 5 times first. So we'll divide both sides by 5. 6 to the 3x equals 4. Then we'll log base 6 both sides to get rid of that 6 to the power. 3x is going to be log x. So x is going to be log base 6 of 4 over 3. So nice and simply, through your calculators, x should be 0.26. Okay, so these ones, nice and simple. Make sure you've use the correct base on your log and it matches the base of whatever the power you are using. Right, some different ones. Now we have a problem. Okay, now hopefully if we just focus on the one on the top left to begin with, what we should hopefully notice straight away is we've got different bases. Now, once we've got different bases, we cannot use log to the base of something to counterbalance it, because as with any equations that you balance, you have to do the same to both sides. So I can't log base through one side and log base to the other side. It's going to give me different answers. I'm not balancing properly. Now, this is where we just use a standard log. Now, this can mean log base 10, but it doesn't matter as long as we use the same to both sides. And then what we can use is our laws of logs that we looked at earlier on last week. Okay, so we'll just have a look at a few and then we'll see where we get to. So at the moment I've got 3 to the x equals 2 to the x plus 1. Now I know I can't use log base something because I've got different powers on different sides. So all I'm going to do is I'm just going to log both sides. Okay, just a generic log. So I'm going to have log to the 3x equals log 2 to the x plus 1. Okay, now I need to find x. Now the great thing is once we're in this, we know using our log laws I can take powers down and put them in front. So I can now manipulate these and I can go x log 3 equals x plus 1 just get rid of that bit. I've just brought my powers down and it's gone in front instead. Okay, nice and simple. Same with this side, the x plus 1's come down in front. If I just sort this side out, so I can expand the brackets out, so I can have x log 3 equals x log 2 plus log 2, so I've just expanded my brackets. Now we should have done this when we were solving equations back in GCSE. Lots of log 3 minus log 2. All I've done is factorised out equals log 2. So x is going to equal log 2 over the top of log 3 minus log 2. Okay, so all I've done here, I've moved my x log 2 over to the other side, outer, factorised that, outer, factorised that, outer, because I've just done it all in one go. And again, straight through your calculators. Once you put that through our calculators, we've got 1.71. Now guys, if you're struggling to find the normal log button, it is under shift and then the negative sign. Okay, so it is in yellow on your calculators along the left hand side, so it's shift and then the negative, and that will give you log. Okay, just basic log. Let's just have a quick look at the next one. So what equals 5. Okay, so we are going to start by the same as before. We will start by logging both sides. Okay, so what we will get is log 2 to the x 3 to the x plus 1. We'll stick that in brackets, equals log 5. Okay, so we log both sides. Now, one of the other log laws we should remember, hopefully, is if we've got something multiplied together, which it is in here, we can separate the logs with an addition. So this will become log 2 to the x plus log of 3 to the x plus 1 equals log to the 5. Okay, now I can drop my power down the same as we did with the last one. So we'll have x log 2 plus x plus 1 log 3 equals log 5. Expand my bracket out. X log 2 plus x log 3 plus log 3 equals log 5. Then manoeuvre my log 3 to the other side and factorise out. I'll just do that all in one go this time. So we'll go with x log 2 plus log 3. So factored out my x from there and move that log 3 to the other side. So I'll have log 5 minus log 3. Then I can divide underneath 5 minus log 3, 5 minus log 3, 5 minus log 3, all over log 2 plus log 3. Stick that in your calculator, guys, and what we should come out with is 0.285. Now, that's if we're answering as a decimal. Now, it's asked you to give it in exact form. Now, technically, logs are in exact form. Now, what I can do with this as well, depending on what I'm asked to do, okay, is I can leave it in terms of logs, but I can actually tidy this up as well. Okay, now I know when I subtract with logs, I can do them as powers. Sorry, not as powers. When I subtract with logs, I can do them as a division. So what I could rewrite that top part as is log 5 over 3. Okay, however, that's not in particularly nice form, so we can leave that as it is because we don't really want to be dealing with fractions inside. However, the bottom, when I'm adding with logs, and it's 4, it's 4, it's 4, it's 4, it's 4, it's 4. So just make sure you are checking what it wants your answers in. You can have it as a decimal, or you can have it in exact form. Okay, so just double check what it's asking you for. If it's asking it for in exact form, make sure you are simplifying, okay? But we don't want to be logging fractions, okay? That wouldn't be exact form then. Just a couple more to show. Again, because we've just got our parts with powers already, we're just going to log straight away. So we'll do log of 3 to the x plus 1 equals log of 4 to the x minus 1. Log to the 4x minus 1. And we can drop our powers down. So we'll have x plus 1 lots of log 3 equals x minus 1 lots of log 4. So we'll go x log 3, so expand your brackets on both sides, plus log 3 equals x log 4 minus log 4. All your x's on one side, so we'll go x log 3 minus x log 4, and move the other parts across, equals minus log 4 minus log 3. Factorise out my x. X lots of log 3 minus log 4 equals minus log 4 minus log 3. So x is going to equal minus log 4 minus log 3 all over log 3 minus log 4. So we'll have x equaling 8.64. Okay, this is why, guys, you've got to be really careful with how you write your logs and use your logs, okay? Because you're going to get to a position where you've got loads of these written on the page. You need to have a good understanding, okay? So layout is really important. It's just a bit more algebraic manipulation. We're just now using logs, okay, rather than basic algebraic variables. Right, last one I want to show you, okay? I will just move to a different colour pen to make it easier to see it. Now, we have looked at stuff like this already, okay? Now, I'm hoping when you look at this that you're seeing straight away what this could look like, okay? We've looked at these in all sorts of different forms now. Now, I'm hoping what you see straight away is that it's more or less a quadratic, okay? Now, what I want you to do is when you spot that, if you can see a substitution to make it a quadratic, that would be brilliant. So what we should see is if I make y equal 2 to the x, this now becomes a quadratic. This now becomes y squared plus y minus 12 equals 0. We can solve our quadratic. So if we factorise to y plus 4 more equals 0, 0, 0, I can have solutions y equals minus 4, y equals 3. However, it's not y, so it's going to be 2 to the x equals minus 4, 2 to the x equals 3. Now, we have used these a lot, okay? We've seen these quite a lot. We've done lots of different work with them, okay? So, now got little exponentials to solve. So, opposite of 2 to the x, back to what we did at the start, we're going to have to log base 2 both sides. Okay, that cancels out the 2 to the power. So I'm going to end up with x equaling log base 2, I'm back to using my bases again in this case, of minus 4. But we can't log a negative, so that one's got no solutions. Same with the other side. We will log base 2, base 2, base 2, base 2, base 2, base 2, base 2 of 3. When we do log base 2 of 3, we should get 1.58. Okay, now guys, we've looked at these ones before. Okay, quite a lot. We've looked at them before. We're just now doing that little bit extra with them. Okay, right. Can you pause now, please? Have a go at the 3 that are on your screen, and then we shall go through them. You may well want to go back to the other examples. Okay, make sure you're rewinding and replaying where you need to. So pause, have a go at those 3, and we will go through them. Please be very careful with the third one. Okay, a little bit trickier, a little bit more difficult. This first one, 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 this first one. Straight away, once we're in this form, I know I've got to log both sides. Okay, so we'll start off with that. So we'll have log 4 to the power of 3x plus 5 equals log 8 to the 4x minus 3, and bring my powers down. 3x plus 5 lots of log 4 equals 4x minus 3 lots of log 8. Expand my brackets out. 3x log 4 plus 5 log 4 equals 4x log 8 minus 3 log 8. All my x's to one side and everything else to the other. So we'll go 3x log 4 minus 4x log 8 is going to equal minus 3 log 8 subtract 5 log 4. Factorise out x, so I'll have x lots of 3 log 4 minus 4 log 8, again equals minus 3 log 8 minus 5 log 4. And finally I can divide underneath, so x is going to equal minus 3 log 8 minus 5 log 4 all over 3 log 4 minus 4 log 8. Now, please, please, please be careful when you put this into your calculators. Okay, it's so easy to make a mistake when putting log into your calculators, so put it in, then double check your display, please. Okay, way, way too easy to make mistakes with these. And your answer will be 3.167. Okay, when you put that through your calculator. Guys, you've got to be really careful using your calculator with these. Right, second one. Again, hopefully noticing it's in a quadratic form already. Okay, we've just got to make the substitution. So the substitution hopefully would be y equals 3 to the x. So we will end up with 3y squared plus y minus 10 equals 0. So we can split and solve this again, guys. You can solve in whatever way you want to. So we'll have 3y squared, 6y, and a minus 5y minus 10 equals 0. So we'll have 3y lots of y plus 2 minus 5 lots of y plus 2. So 3y minus 5 and y plus 2 equals 0. So we'll have y equals 5 over 3, y equals minus 2. So loads of different ways to solve the quadratic, guys. Just make sure you are showing it. You aren't just using your quadratic solver and your calculators. Do not lose easy marks. Okay. Remember, we're not actually trying to find y at this point. We're trying to find x. So let's just go up there. So what we've actually got is we've got 3 to the x equals 5 over 3. And we've got 3 to the x equals minus 2. Inverses will be log base 3 of both sides. Okay, because that then cancels out that 3. So I'll have x equals log base 3 of 5 over 3, which you can put into your calculator as 0.46. And this one, because I've got a negative here, as soon as I try and log it, I am not going to get a solution. Okay, so the only answer I have is going to be 0.46. Right, the last one I gave you, you've got to be really, really careful. It is still a quadratic. It is still one you've got to solve. Okay, just make sure your substitution is correct. Now, your substitution, hopefully, is 2 to the x still. Okay, now what that means is when we substitute this in, I'm going to end up with y squared minus, now 2 to the x plus 1. I'm going to separate that, and what I'm going to do is I'm going to say that is 2 to the x times by 2 to the 1. Okay, basic index laws. So what that ends up meaning is that's going to be minus 2 lots of 2 to the x is now y times by 2. So that's 2y. Okay, just a little bit of manipulation using index laws. Okay, to then put me in a nice simple quadratic form. Okay, solve my quadratic. So we'll have y minus 6 and y plus 2. So y equals 6 and y equals minus 2. I'm actually after x. So we'll have 2 to the x equals 6. 2 to the x equals minus 2. Hopefully we're getting used to now spotting this will never be able to happen. 2 to the x equals minus 2 is not possible, so that's not going to give me any solutions. This side, inverse of 2 to the power of something is to do log base 2 of both sides to counteract the 2. So x is going to equal log base 2 of 6, which is going to be 2.58. Now be careful, because it's not always the case that you get only one side gets solutions. You have got to be careful. You may want to rewatch this, guys, especially the little nitty-gritty bits with the manipulation with logs. Okay, again, only one exercise for you to do today, because it is going to be a bit trickier. Okay, so if you can go through for me and have a go at the questions that I've asked you to do, make sure you email me if you need any help. Okay,